Hello children, this is your physics teacher Sharma and I welcome you all back to my class again. In today's class, we will be discussing about concept of ion, definition of ionic compound and properties of ionic compounds. Let us start with the basic question. What is an ion? In the previous class, we have learned that atoms either lose or gain electrons to attain stability. In the course of gaining or losing electrons, the point we should note is that it is also becoming charged. Okay, when the number of electrons, in case of atom gaining an electron, the number of electrons is becoming more than the number of protons, so it is becoming negatively charged. On the other hand, when an atom is losing electrons, the number of electrons is becoming less than the number of protons, so it is becoming positively charged. Okay, that's the reason why we see all metals being positively charged because they lose electrons, and all non-metals are negatively charged because they gain electrons. So, an atom either loses or gains electron to become a charged particle, and that charged particle is called ion. Now, the compound that is formed because of the force of attraction between two oppositely charged ions, that compound is called ionic compound. This ionic compound necessarily forms between a metal and a non-metal. You see any ionic compound, it will have a metal and a non-metal. However, there are some exceptions in case of compound radicals. For example, if we take sulfate ion, SO4 2-, sulfur and oxygen taken together will have a charge of 2-. That is an exception. Those kind of compound radicals are exceptions. But basic level, ionic compounds are the compounds that are formed due to the reaction between a metal and a non-metal, or a metallic ion and a non-metallic ion. And how ions are formed, we have already learnt in the previous class. Now let us look at the properties of these ionic compounds. As a part of that, we will be discussing about the physical nature of the ionic compound, melting and boiling points of ionic compound, solubility of ionic compounds, and conductivity of ionic compounds. Okay. First, starting with the physical nature. Remember, there is a strong force of attraction between these two oppositely charged particles. These compounds are formed because of charged particles between which there is a very strong force of attraction. And because of this strong force of attraction, they are usually very hard and they are not very easy to break. They are not brittle as well. Okay, so coming to the physical nature of ionic compounds, they are very hard. Okay, usually. Now, coming to the melting and boiling points. What actually is happening when we are heating a substance? Okay, definitely a solid will melt, but if you try to read between these two processes, the heat energy what we are supplying is actually breaking the force of attraction between two particles. And that's the reason why the gap increases and so the solid changes into liquid state. We say the iron is melted and recasted, right? Now melting, this solid iron is changing or flowing like a liquid. That is happening because the force of attraction between particles is made less by giving more amount of heat energy. Okay, now in case of ionic compounds, we say that they are having a very strong force of attraction. Automatically, when the force of attraction is very strong, the amount of heat energy that is required to make the force of attraction less, to decrease the force of attraction, is also very high. So we have to give more amount of heat energy to any ionic compound so that it becomes soft and melts and starts flowing. Okay. Obviously, when the melting point is so high, the boiling point will be much higher. So, for ionic compounds, the melting and the boiling points both are very high because they have a very strong intermolecular force of attraction or interatomic, interionic force of attraction. Now, coming to solubility. These compounds we say polar compounds. We call these compounds as polar compounds because they are formed because of charged particles. These are having positively and negatively charged particles present in them. Hence, they dissolve only in polar solvents. Now, what is this polarity? What is the meaning of polar solvent? Do we have non-polar solvent? Let me explain you. If we take water molecule, water is made up of hydrogen and oxygen, and shape of water molecule is V shape. We have seen that oxygen having more number of protons, it attracts the electron of hydrogen towards it. So this end becomes slightly positively charged, and as hydrogen is losing electrons, it becomes slightly negatively charged. Now, as a whole, if we see this end is positively charged and this end is negatively charged, that means there is a polarity in each and every molecule of water. Now, this is a polar compound and water is a liquid. So, we say it is a polar solution. We say it is a polar liquid. And water is a very good solvent. It can dissolve many things in it. So, we say it is a polar solvent. As water is polar in nature and it can dissolve many things in it, we say water is a polar solvent. And these compounds also are polar in nature because they are having charged particles in them. And remember the phrase like dissolves in like. That means only polar compounds like sodium chloride, magnesium chloride, these kind of compounds which are formed because of ions, those only will dissolve in water. You can do a small activity in your house. Take a pinch of salt, add it to water. You will see it immediately dissolves. Take a pinch of salt, add it to a little quantity of oil. You will see that the salt does not dissolve in oil. It always settles at the bottom. This clearly shows that oil, which is a non-polar compound, it does not dissolve sodium chloride, which is a polar compound. So, a non-polar solvent cannot dissolve a polar solvent in it. Now, try the other way around. Take a small piece of camphor or naphthalene ball, add it to water. You will see it will not dissolve in water. That same camphor or naphthalene, you add that to coconut oil. You will see it immediately dissolves. Camphor or naphthalene, these two are non-polar compounds, and oil is also a non-polar compound. That's the reason why these non-polar compounds dissolve in non-polar solvent. Okay, so remember, like dissolves in like. So these ionic compounds, being polar compounds, they dissolve in polar solvent, that is water. Now, look into the conductivity of electricity. As these compounds are made up of ions, immediately we will be jumping to the conclusion that these will be very good conductors of electricity, which is a blunder. No ionic compound is a good conductor of electricity as long as it is in its solid state. Remember, for the conductance of electricity, it needs free ions. Here, none of the ions are free. Every ion is jam-packed as it is associated with the other ions around it. So, it does not have free ions. They will have free ions only when the bonding is made loose, weak, or it is completely broken. This can happen only when we make an aqueous solution of that compound or we melt it. Suppose if I take sodium chloride. Sodium chloride will not conduct electricity as long as it is in its solid state. But it will start conducting electricity when I add water to it. That means it will conduct electricity. Electric current will pass through salt solution but not salt. Similarly, if I boil it, if I melt this sodium chloride, then yes, it actually conducts electricity. So these are the properties of ionic compounds. Hope we are clear with this concept. This is all for today. We'll see you in the next class. Until then, have a nice time.